Hello everyone, my name is Kanishk. I'm here to explain you moment of force about a point 2D. So first of all, let us get to know what is moment. So here we have moment of force about a point 2D. So basically it might seem complicated by reading this, but moment is actually simple. Moment is equal to force into the perpendicular distance. So what is a moment? Moment is actually force into the perpendicular distance. So there are two conditions. There are two conditions which we have to take into the action, that is clockwise as well as counterclockwise or anti-clockwise. So it is the clockwise and it is the anti-clockwise. So here we take the clockwise rotation as negative. So just make sure the clockwise direction we take it as negative and the anti-clockwise direction we take it as positive over here. So to understand more about this moment, let us jump into a question so that I will get to know more about moment. So here's the question. So the question basically given, it is given that a tower crane lifts a 3 mg load. The 2 mg BD, 1 mg BC, and 5 mg counterweight C have centers of mass at G1, G2, G3 respectively. So there is something different over here. All the points given here is kind of equal. That is 2 mg BD, 1 mg BC, but here 5 mg counterweight C. The counterweight C is different. We have to make sure, like, we have to read the question twice or thrice to understand more about the question. So it's given that counterweight C, and here determine the resultant moment produced by the load and weight about point A and about point B. Point B is over here, point A is over here. So now let us get to know how to solve the question. So first thing what we have to do is draw the free body diagram. Okay, so whenever you get a question, first thing to do is draw a free body diagram. So we drew a free body diagram. Point B is over here, point A is over here. So we have the W, that's 3 mg, W1 2 mg, W2 is 1 mg, and W3 is 5 mg, and the respective distance is also given. The distance between the point A and B to the W1 is 9 meter, to the point W is 12 meter, to the point W2 is 3 meter given over here, and to the point W3 is 11 meter respectively. So now the vertical distance here given is 20 meter. The vertical distance given from point A to point B, the distance is 20 meter. So we drew the free body diagram. Now it's time for us to resolve the problem. Okay. Now when we get into resolving the problem, we have, okay, first of all, I've mentioned all the given. So I've listed the given items over here. One thing to be noted here is that, so we have point B, point A, and this is the point B and point A. The distance between them is 20 meter. Okay, so all the forces over here act vertically downwards. Even if it's in the left side or right side, it acts vertically downwards, right? As we saw in the free body diagram as well as in the question, everything acts downwards. That is parallel to A and B, right? Parallel to A and B. So that's what is given here from the figure. All the weights and loads are acting downward parallel to AB. So the moment at A and moment at B will be same. You might think how it's possible. What did I say moment is? What did I say moment is? So moment is basically force into the perpendicular distance. Here the force is given, the perpendicular distance for point A and point B is same since it is parallel. All the weights acting is downwards and parallel to A and B. So technically that means for both A and B the moment will be same. That means we have to find it either the moment at A or moment at B. So let us consider the moment at A over here. So that is force in the perpendicular distance, W into RA1, W1 into RA1 AW1, W2 into RAW2 minus W3 into RAW3. The reason for minus over here is that it has been mentioned that counterweight. The counterweight is mentioned over there, which is negatively taken over here. You got my point? It has been mentioned as counterweight, so it is in the opposite direction. We take it as negative. So resolving that, 3 into 12, this is 3 into 12, and here 2 into 9 is this, and 1 into 3 is this, and minus 5 into 11 is this. So when you take, just a second, okay, when we take, it is 36 plus 18 plus 3 minus 55, which gives you 2 mg dot m. So if you need the unit in Newton meter, what we have to do? Okay, so if they ask to write the answer in Newton meter, they ask you to write the answer in Newton meter, what do you have to do? So it's basically simple. So if you need the answer in Newton meter, what you have to do is multiply that with G, that is 9.81. All you have to do is multiply by 9.81. Here I'm not doing it, I'm letting the values to be in mgm. Okay, so now let us check it to the moment at B. So as I said, the moment at A and moment at B will be same. So here it's the same procedure. Moment at B, when we take it as 3 into 12, 2 into 9, 1 into 3 minus 5 into 11, because it was given as counterweight, so it's taken as negative. So that is 36 plus 18 plus 3 minus 55, which gives you 2. As I said, if you want in Newton meter, you have to multiply it into 9.81. So that's it. And here I have given the point for both the points A and B. The height does not factor into the moment equation because all the forces are acting vertically downwards. All the forces are acting vertically downwards, and there is no force that is acting horizontally. So the moment at A, the moment at A will be equal to the moment at A will be equal to the moment at B. So yes, that's it about the question. I guess hope you all understood about the question. The one main thing to be noted is that the direction of the weight load acting, if it is clockwise or anti-clockwise, you have to take that accordingly. And also in this particular question, the force were all acting vertically downwards, which was parallel to A and B, and hence the moment is same for both A and B. It might vary, so you have to check that and write it down. So I hope you all understood about this question. Thank you.